Okay, so Friday, you guys have a Math Excel assignment. Hey guys, I'm talking now, so everybody needs to be quiet. You have a Math Excel assignment that is due by the end of the day tomorrow. We are finishing this section today, and tomorrow we will be moving on. We were talking about graphing quadratics, and we said if it's written in what was called the vertex form, the a times x minus h squared plus k, then it was really easy to do it with transformations. And if I gave you something like that, my suggestion would be to plot your parent function and do transformations just like we did in the last chapter. If it was not written in that form, if it was in standard form, like this problem up here, the transformations aren't as obvious. So what did we have to do to find our vertex? Opposite of b over 2a. Okay, so this question says, without graphing, find the vertex and axis of symmetry. Does it open up or down? So to find the vertex, we are just going to do opposite of b over 2a. That's that formula that I gave you, you need to know. So opposite of b would be negative 6 over 2a is negative 3. So we get 1. Then what do you do with that?
Plug it back in.
Plug it in to find your y. So we get negative 3 plus 6 plus 1, so that is 4. So our vertex, 1 comma 4. Axis, how did I want the axis written? X equals 1, the x value. Does this open up or down? How do you know? Okay. So does that mean it has a maximum or a minimum if I ask that question? Maximum. Okay, you guys do B and C, please. Okay, so the first one, you got opposite of b over 2a gave you 1 again. Plug 1 in, you got 3, so your vertex is your pair 1, 3. You guys prove that? Axis symmetry, make sure it's an equation. It's x equals the x value of your vertex, so x equals 1. Does this one open up or down? Up, because of the positive coefficient. So would it have a maximum or a minimum if I asked for that? Minimum. Good. Okay, last one. If we do opposite of b over 2a, so that would give me a positive 4 over 2 times negative 8, and you get, you plug a negative 1/4 in. Negative 9.5? Is that what you guys got? Nobody's screaming now. Or negative 19 over 2 if you wrote it in fraction form. Okay, so vertex. It's just that ordered pair. It doesn't matter if you use fractions or decimals. Axis is x equals the x value of the vertex, so x equals negative 1/4. And did this one open up or down? Down, because it was a negative square. So that was kind of a review from last week. That was where we ended up off. We had talked about finding the vertex using our formula. Any issues with that at all? Then let's look at, I want to just talk about some quadratic models that we're going to see. A quadratic is something that often comes up when we're talking about motion. more specifically, if we're talking about vertical motion, if you have a quadratic, I may ask you a lot of times to find a maximum or a minimum value. That's just finding the vertex. You had some of that on the Math Excel assignment, I believe, as well. The maximum or minimum is the actual highest or lowest y value. One equation we will be using a lot is for height of an object. So S of t equals negative 16t squared plus v sub 0t plus h sub 0. You want to make sure you write this down. It tells us you at the bottom what these variables represent. V sub 0 is your initial velocity, h sub 0 is initial height, t is time in seconds, and the s is your height at a given time. On tests or quizzes, I may ask you to use this equation. I will give you this part right here. I'm not going to tell you what all the variables stand for because you should be familiar enough after using it a few times to be able to remember that part. But I would not expect you to remember this equation at this point. If you've had physics, I think you use this equation a lot in physics, so you might have seen it before this point. Does everybody have that part written down? So let's look at a problem. A ball is thrown directly upward from an initial height of 75 feet with an initial velocity of 112 feet per second. Part A, give a function that describes the height of the ball in terms of time t. So this is vertical motion, so we are going to use that equation that I just gave you. So the version I gave you, I said S of t equals negative 16t squared plus v sub 0t plus h sub 0. In this, what you need to do is plug in values for h and v. V was our beginning velocity. What is the beginning velocity here? So it's negative 16t squared plus 112t plus h sub 0 was our beginning height. What if I said you started on the ground? What would your beginning height be then? 0. All right. Part B. After how many seconds does the projectile reach its maximum height? And what is the maximum height? I meant to say. That's supposed to go on the next one. There. Okay. How do you find a maximum? What am I asking you for?
The highest y value?
So how do you get? Where does that occur? What's the name of that point? The vertex. Didn't we just find the vertex in the last 3 problems? We need to do opposite of b over 2a. So I have my quadratic equation. So opposite of b, so negative 112 over 2 times negative 16. Gives me 3.5. What is the 3.5 my maximum height?
No, it's your x.
Right, that's my x, which in this case was t. So this means it's after 3.5 seconds. That's when we hit our highest value. So now to actually find that highest value, you have to plug a 3.5 into your equation. What does that give you? $271, and that would be 8. So we hit our highest value after 3.5 seconds. The actual highest value is 271 feet, just from our vertex one. Is that one okay? teach you guys how to do a few things on your graphing calculators. I want, for what interval of time is the height greater than 200? So my height is given by this equation. And I want that to be bigger than 200. Okay, we are going to use the graphing calculator to solve this. So everybody needs one right now. If you don't have one, go ahead and grab it. We are going to go to our y equals. And we are going to graph two things. So my y1 is going to be the left-hand side of this equation. So negative 16, we don't have a t button, so you're just going to use x. So negative 16x squared plus 112x plus 75. My y2, I'm going to make that the right-hand side of my equation. So I want it to hit a height of 200. So we're all on the same page. Let's kind of reset our calculator so we're all looking at the same window to start with. If you would, go zoom number 6 for me. So hit zoom and then 6. That's going to reset all of our windows so we're all looking at the same thing. Now, if I look at that, does that show me much? No. This is set to the standard viewing window. So you're looking from negative 10 to positive 10. I am trying to figure out when this thing hits a height of 200. So is a y value of 10 going to be high enough here? Okay. I want you to hit window. So second one up here at the top, window. This will allow us to change what we're looking at. We are trying to see where this quadratic hits a height of 200. So would I really need a negative height here? No. Now, it's only at negative 10, so that's not a big deal. Would you really have to have a negative x value? Would we have negative times? No. You can leave those things, it's not a big deal, but what we really want to change down here is this y max. Okay, so let's go down to this y max. That's the highest value your calculator is showing you. We need it to be at least 200, so I'm going to make mine 250. And then just to help my calculator out, right below that it has y SCL. That's your y scale. It's what your calculator counts by. If you're going all the way up to 250 and you count by ones, it's going to take your calculator a little bit to get there. I'm just going to adjust that to a 10 just to speed it up. It's not a big deal if you don't. It'll just kind of help us. Then hit the graph button. So let's see. Sometimes it's kind of a guess and check. You might have to change things more than once. So I get my parabola. I don't see the highest point, but I don't necessarily have to. And then I see where it equals the 200. Everyone have that on their calculator screen right now. We need to know when my height is greater than 200. So would you guys all agree, if we have something like this, there's your height, here's your 200, it's greater than in between these 2 points. Would you guys agree with that? Yeah. Okay. So we are going to give an interval of time, starting here and ending here. We need to find those points exactly. If you just try moving your cursor, you're not going to get the exact point, but your calculator can find it for you. So you need to hit second, and then the trace button. This takes you into the menu of everything your calculator can find. So second second trace. If you want to find the point where two graphs meet, what is that called? Look at your list of options. Which one do you think it is? Intersect. So number 5. So second trace, number 5. Everybody there? Okay, now you'll notice it's asking me questions. First curve. We only have 2 things entered. We had a y1 and a y2, so your calculator will use those 2 automatically. All you have to do is hit enter. So first curve, we're just going to hit enter. Second curve, we're just going to hit enter. Then it asks you for a guess. You just need to use your cursor and get close to the point that we're looking for. So I'm finding this first one. So first curve, enter. Second curve, hit enter. Get close to it and hit enter. And then it says intersection, and it tells us the x value is 1.393. Is that what you guys got? Now let's find the second one. So to find the second point, you repeat that process. You have to start back with second trace. Intersect is number 5. First curve, you just hit enter. Second curve, just hit enter. But this time for my guess, I want my second point, so I'm just going to move my cursor over to that point. And hit enter. And that one tells me 5.687.
Not 606.
Yeah,
606, but then it did have a 5 after that. I'm just rounding.
yeah.
Yeah, it's not 8 though.
It's 0. It's really fuzzy on the vector. I have a hard time reading it. Okay.
Did anyone have trouble finding? So I can just write it as like.
And you could say it. You could do an interval. That would be fine too. Okay. Part D. There are a couple ways of doing this, but since we just learned one method, I want to do it the same way. If it hits the ground, what is your height? 0. So I want my height equation to equal 0. So I'm going to do that on my calculator. There are 2 different ways your calculator can do this, but I'm going to do it just like we were doing. So go back to your y equals. What do I need to change? My y2, I want it to equal 0. So I'm just going to change y2 to 0. Then graph. So this time our parabola didn't change. Our horizontal line is our y-axis. Now it technically hits twice. How do I know which one I want? The second one. This one's going to be at a negative time. Would that even make sense? No. Your product, or whatever, the ball was going up and coming back down. I need the second one. So let's do it the same way. Second, trace, intersect is number 5. First curve, enter. Second curve, enter. Guess. We're getting close to that second point over there. And hit enter. And 7.616. Okay. What questions do you guys have? examples like this. I didn't print any more on your notes handout, but I have more. Do we need to do another one to practice finding things on the calculator? You guys think you can do it? Okay. So you have 2 things due tomorrow. If you have not finished the Math Excel, you need to get that done. It was all the stuff that we did Friday, so you should have been able to get it done, but if you have not, that is due tomorrow. I also posted a handout on Classroom. A lot of the handout is review, like what we were doing, finding maximums, minimums, domain range, graphing your quadratics. So there's some stuff like Friday, and then there's some like what we just did. So you've got quite a bit of time right now to work and ask for help if you need it. Tomorrow, we are also going to have a quiz. So the things that we've done in this chapter, we talked about the complex numbers in the first section. So remember breaking down those radicals, if they have an I in them, adding, subtracting, multiplying, dividing complex numbers, and then the quadratic stuff. So this handout is pretty good, pretty comprehensive over the section. 1 through 4, it's like stuff we're doing Friday. So you will expect 1 or 2 of those on your quiz, and then the quadratic example like we just did is problem 5. So quiz tomorrow over complex